Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about natural logarithms. In the last video we talked about common logarithms, and when we were talking about common logarithms, we were talking about logarithms that had a base of 10. This video we're going to be talking about natural logarithms, and the base is not a number that's as easy to work with as 10. In fact, it's a very awkward number to work with. It's an irrational number. That goes on forever, very similar to pi. It's been found to, it's called the natural base of logarithms because it's tied to a lot of naturally occurring events. And if you do any work in chemistry and electronics, radioactive decay, growth, population growth, all sorts of naturally occurring events, this number is a very useful number, just like pi is a very useful number when we're dealing with circles. So we've understand that when you see a small letter e, we use that to represent this irrational number. That's very useful, and it's certainly very useful as a base for logarithms. So let's talk first about the notation. When you have log base e, instead of writing log base e, it's been decided to use another symbol to represent that, and that's ln. For natural log, but I think it's Latin for log natural. I mean, I don't know the exact Latin term. But when you see this, understand that this is what it means. We just don't write the word log and base e. We replace this with ln, but we understand that it means log base e. Just like when we say log written without a base, we understand it means base 10. So let's talk about how we calculate logs with a natural base and as well as antilogs. On your calculator, you will have an ln function. So on your calculators, most calculators, they will only have two log keys, one for base 10 and one for base e. So this isn't the word in, it's ln for natural log. Let's talk about how we use that to find the natural log of a variety of numbers. All right, you may be given instructions to find the natural log of a variety of quantities, and all you're going to use is your natural log key on your calculator. Some of you will enter natural log and then your quantity. Some will enter the quantity and then the natural log function. In either case, you're finding what power e must be raised to equal 25. That's what you're doing when you're asked to find logarithms. You're finding the exponent to which the base, in this case e, must be raised to equal to the quantity. So if we plug it in, first example, we should get 3.219. I'll just do these to 3 decimal places. So try it on your calculator, make sure you know how to do it, and you get the same result. Second example, again, I'm finding what must e be raised to equal 1,050. And when we punch that in, 6.957. If you punch natural log of 1 in your calculator, you're going to get a 0, and you might think you did something wrong, but you didn't. The log of the log of 1 to any base is always going to be 0. In other words, e to the 0 is equal to 1. So the natural log of 1 will always be 0. And the last one, because this number is less than 1, we should expect to see a negative exponent. What must e be raised to equal 0.4. Plug it in, and you should get negative 0.916. It's harder to check and estimate when we're dealing with base e as opposed to base 10. Base 10 was much easier, but base e is the base of logarithms you're going to be working with most often when you get into higher math and into calculus and applications. So you want to get comfortable with it, even though it's a little more awkward. It's still the same process. Let's take a look at taking the natural antilog of numbers next. Okay, so the instructions that you might see might be similar to this, where it says find the natural antilogarithm of the following. So the key here is natural, means it's base e, and antilog means it's not logarithm, it's the inverse. So we're finding the quantity when we know the exponent. You'll have a function on your calculator that's going to probably be above your natural log function. It'll be the inverse of that, and it looks like this, e to the x. So that's the key that you're going to use when you're finding the natural antilog. The question might be written differently. It might say something like this: 2.4 is equal to the natural log of some quantity. So find that quantity. So whether it's written in this form or like this, it's the same process. Basically, you're finding e to the 2.4. Because if we went into exponential notation from here, my base is e, my exponent is 2.4, e to the 2.4 equals q. So that's what I'm evaluating. That's what I'm evaluating here. When I'm finding the antilog, I'm finding, and it's natural, I'm finding e to that exponent. All right, so try that function on your calculator with these examples. First example, we should get 11.02. Okay, so check with your calculator. Next example, e to the 1. If you know what e is, 2.718, you won't even need your calculator, but if you don't know what e is, then just go e to the 1 and you'll find out. Now we're getting into negative exponents. So I'm finding e to the negative 3. I know that I'm going to have a value or quantity less than 1. When we punch that in, we get 0.05. And the last example is another negative exponent, e to the negative 1.2. That will equal 0.301. I'm not consistent with how many decimal places. That's not important at this point. It's just understanding how to use that function on your calculator. So understand how to find the natural logarithm of a number. In other words, you're finding the exponent when you know the quantity. Know how to find the natural antilog. In other words, find the quantity when you know the exponent. And be comfortable using those functions on your calculator. You're going to see this come up if you continue with your math studies. You're going to see natural logarithms in many different applications. So you want to get comfortable. We're going to see them when we look at log equations in the next video. So you'll see some applications at that point. Practice with your calculator, get confident, and we'll see you on the next video.